Alright, this is my rigid body equilibrium reassessment. A 12.2 meter crane weighs 18 kilonewtons and is lifting a 67 kilonewton load. The hoisting cable tension 2 passes over a pulley at the top of the crane and attaches to an electric winch in the cab. The pendant cable tension 2, which supports the crane, is fixed to the top of the crane. Find the tension in the two cables and the force at the pivot. So this is the picture of the crane. It's 12.2 meters. These are the two cables, tension 1, tension 2. Tension 1 goes to a winch inside the cab. It is 18 kilonewtons, and the object in which it's lifting is 67 kilonewtons. So I went ahead and drew a force body diagram, and I have my force of the object pulling down, which is 67 kilonewtons, and I have my tension 1 pulling up and on this cable as well, and then I have tension 2 is a stationary cable that connects to the top of the boom to the body of the crane. Then I also marked this point as point O to use later in the problem. So let me just rearrange these. Alright. Oh, wasting time. So pulley, the sum of the forces in the y direction equals 0. Tension 1 minus 67 kilonewtons equals 0. So tension 1 equals 67 kilonewtons. At point O, the sum of the forces in the y direction equals 0. This is all one equation. I just ran out of room, so I have T2 times 12.2 meters sine 10 plus tension 1 12.2 meters sine 5 minus 18 kilonewtons times 6.1 meters sine 40 minus 67 kilonewtons, and times 12.2 sine 40 equals 0. Then I go to simplify it, and algebraically I got 247.7 kilonewtons. And then for the pivot, the sum of the forces in the y direction equals 0. I put force of the pivot in the y direction minus 18 kilonewtons minus 67 kilonewtons minus tension 1 cosine 45 degrees minus tension 2 cosine 50 degrees equals 0. Then I simplified, solved for the force of the pivot in the y direction, and that gave me 291.6 kilonewtons. I did the same thing for the x. Sum of the forces in the x direction equals 0. And I plugged in what I knew and solved it, and got the force of the pivot in the x direction is 237.1 kilonewtons. And then the magnitude of the force, I took both of those numbers, square rooted them, and well, they're squared, and then square root of those numbers, and that gave me 375.8 kilonewtons. And to find the direction, I took theta equals inverse tangent 291 divided by 237.1, which gave me 50.88 degrees. And then so my magnitude is forces on the pivot equal 375.8 kilonewtons at 50.88 degrees with the horizontal. And that is my rigid body equilibrium.